Good morning, everyone. Today I'm gonna talk about more about the circuit, and then before I talk about it, I'm gonna talk about first voltage and current measure. So there are two meters, voltage meter and current meter. So which is called ammeter. So the both because they are in series, right? The ammeter and resistor have the same current. So this is actually how you connect your ammeter in series with the resistor. Okay, so ammeter you connect ammeter and resistor in series. Okay, so the resistance of an either ammeter is zero because ammeter itself another electrical device, so it has its own resistance, right? So that it can measure the current without changing the current. What it means here is actually, let's assume we are measuring the current, and then ammeter, for example, is an ideal one whose resistance is zero. So then we have a battery 1.5 volt, and then assuming the resistance is for example 1.5 ohm as well. So then your current, the ideal current that you're gonna measure, so forget about this number, it's gonna be your I, real I is 1.5 divided by 1.5. So what you're gonna measure is 1 ampere. That's exactly what you want. But let's assume this ammeter is not ideal, and then let's say its resistance is, for example, 2 ohm. So then Req for the, the resistance is 1.5 ohm. So then your total Req is gonna be 3 ohm, right? Which is a 1.5 plus 1.5, right? So then your current then is you still have the same battery, but your Req is now 30 volt. So what you're gonna measure is a zero point 0.5 volt ampere, right? Which reduces your current a lot, right? So if you have a high value resistance, and because your Req is gonna be R original plus R over M matter, right? So you wanna minimize this number, because why? Your total current is gonna be your voltage plus a Req, and that is a R plus R M matter, right? So if you minimize this value, the I value was original value V over R, right? That's exactly what we want. So for ideal, ammeter, your RA must be 0, okay? And then voltmeter is the different. Again, the voltmeter itself also has a resistance, right? Because the voltmeter itself is a electric device. So then we connect the voltmeter in series. For example, if you want to measure the voltage drop across this, then you have to make a this voltage drop, connect like your voltmeter like in parallel, right? So what it means here is initial resistance was a 24 ampere, right? But because you connect your voltmeter in parallel, right? So then Req, which is the combination of these 24 and V volt, is gonna be 1 over, sorry, this is 1 over 24 plus 1 over resistance of a voltmeter, right? But you want Req 24, right? So that means that this value must be 0. So in order to have this value 0, you have a RV infinite, right? So if we resistance of the voltmeter is infinite, then this term will be 0. Then your Req is come back to the original value, which is a 24. So an ideal voltmeter has an infinite resistance, but practically that's not possible. So we need a very high value of resistance for our voltmeter. Again, two things. Ammeter, you gotta connect it in series and with a very small resistance. Voltmeter, you have to connect it in parallel with a high resistance. Mhm. So what does the voltmeter read here, right? So the voltage here is basically 6 up, and then this one must have a voltage 6 down. So, and this is a parallel connection. So the voltage drop across this resistor must be 6 volt as well, right? So the answer is a. And now I'm gonna talk about more complex circuit. So for example, we have this type of a more complex circuit, right? But basically, our goal is to simplify this circuit with a single resistor, which is a Req, right? To find the total current I, right? So then in order to do this, we have to simplify these two first. So then this is in parallel. So the combination of these two is going to be 1 over 90 plus 1 over 45, which is a 90 plus times 3 over 90. So this is 130. So this is 1 over Req. So the combination of these two is going to be 30. And then this one and this one in parallel, right? So you got to add them. The combination of all this is going to be 40. But this one and this one again in parallel. So your final Req, 1 over Req is going to be 1 over 40 plus 1 over 60, which is 123 plus 2, which is 5 over 120, which is 24 volt. Sorry, 1 over, sorry, this is going to be 1 over 24. So that means Req is going to be 24 ohm. So the answer for this question is Req is simply 24 ohm. Okay. So in addition to that, we can also, yeah, that's it, right? And then next one, the similar thing. So then find the current through the potential differences across each of the 4 resistances. So basically your goal is finding what is the current I here, what is the voltage here, what is the current I here, what is the voltage here, what is the current I here, voltage, what is I, what is your V. And then in addition to that, we also need what is the total current I as well. So in order to find the total current I, you have to simplify, you have to find the Req, right? In order to find the Req, you have to simplify these two circuits, which is in parallel. So the combination of these two is going to be 1 over 600 plus 1 over 400, which is 1, 2, 0, 0. This one will give you 2, this one will give you 3. Again, this is 1, 2, 0, 0, 5, which is 2, 4, 0, 1, right? So that means the combination of these two is 2, 4, 0, and this one in series, right? So you have to add 2, 4, 0 plus 5, 6, 0, which is 7, 800. So the combination of these three resistors is 800, and this combination and the other combination here, 800, are in parallel. So the final 1 over EQ is going to be 1 over 800 plus 1 over 800, which is 1 over 400. So your Req is going to be 400. So then you can say my Req is 400 ohm. So then your I is going to be 12 over 400, right? That is your current, right? Can we divide 12 over 400? Let me see. No, that's not possible, right? So if you divide by 400, 4, so then this is gonna be 100, and this is gonna be 3, right? So this is your current, total current, right? So then what can you say at this point is my total current is 0.03 ampere. So let me rewrite this. My total current is 0.03 ampere. So your I is gonna be 0.03 ampere, right? So let me double check it. the total current is 30 milliampere, right? That's correct, right? So then now, what can we do next? So we are looking for every single value of I and V for each resistor. And then again, I is the total amount of water flowing in this pipe, right? And then it will split here and here, right? So we don't know how much water will flow this way and the other way. But what we can know here is the voltage drop here is a 12 volt, which means if I go this way, this is the only waterfall you will see. So whose height must be 12 volt. So then now, because you know the 800 resistance and then voltage, your current here is a 12 over 800, right? This is your current. And then because now you know the current here, rest of the current here will flow this way, right? So then how much current do we really have here? This is gonna be 0.03 minus 12 over 800, right? And then your voltage drop, you can calculate V is IR. So whatever I value you have times 560 will be the voltage drop across here. Let me find the actual number. So the voltage drop is here is 15 milliampere, 15 milliampere, right? So then this is half and half, right? So this is actually, you see, this is 0.015 ampere. So that means that this is 0.015 ampere, right? So then your voltage drop across here is 0.015 times 560, right? So then the number you see is going to be 8.4. So then that is 8.4 volt, right? So then now you have a 8.4 volt drop total out of 12 volt. So that means you have a 3.6 voltage drop left. So then here 3.6, and this is a 3.6 as well. So then your I is gonna be 3.6 divided by 600 here. Your I here is a 3.6 divided by 400. So this is actually how you find all current and voltage across each resistor, right? And then next one, same, right? So first thing is you have to find what is REQ, and then later you will find the I and V here, I and V here, I and V here. But you have to simplify these two first. 1 over 10 plus 1 over 10 is a 1 over 5. So this combination is a 5 ohm. And then these 5 is are in series, right? So you have a total 10 ohm. So your REQ is going to be 10 ohm. And your total current is 10 volt divided by 10 ohm, which is 1 ampere. So the total 1 gallon of water is flowing 1 ampere. And then you have a split, but you don't know how much, you know, you have each of this. But anyway, they merge here and then come back, right? So your this I is again 1 ampere. So then you can find the voltage drop is IR, so which is a 5 volt, right? So then initially you have a 10 volt up, and then later you have a 5 volt down. So that means each voltage drop across each resistor, this one gonna be minus 5 volt. This is a 5 volt. So then your I here is a V over 10. Here is a V over 10, which is a 0.5 ampere, which is a 0.5 ampere. This makes sense because you initially have a 1 ampere, right? And then half a gallon flowing here, which corresponds to 0.5, and another half a gallon here, makes sense. And then they merge at one point and then flow together as a 1 gallon, right? So this everything makes sense, right? And then in terms of a voltage, this makes sense. Initially ground, you go up 10 volt high. And then if you go this way, 5 down. So now your height is 5. And then you see another waterfall, which gives you another 5 volt down, so come back ground. And then if you go this way, 10 up, 5 down, and 5 down, come back to the ground, right? So you can always double check your final answer, for this kind of a circuit question, so you're never gonna make a mistake, okay? So after you solve, in other words, finding all I's and V's, make sure you can double check your answers all the time, okay? Okay, last one. What is the REQ here? Again, we got to do it one by one. So then you see these two are in series, right? So these two combination will be 15 ohm. And then this 15 ohm and this one are in parallel, right? So the combination of these is going to be 1 over 15 plus 1 over 15 is 1 over R, right? So then this is a 2 over 30, 15, which is a 1 over 7.5, which is a 1 over R, right? So this all three combination is a 7.5. And then 7.5 plus 2 plus 2.5, so these two combination is again 10 ohm. And then 10 ohm in parallel, right? So again, you have a 1 over R equals 1 over 10 plus 1 over 10 is 1 over 5. So the whole combination is a 5. And then this whole 5 and this 5 is, they are in parallel, right? So your final REQ is going to be 5 plus 5, which is a 10, right? So then, for example, let's assume we connect the battery that is a 10 volt. Then your current will be 1 ampere. And then you can solve everything one by one, finding, what is I here, what is V here, what is I here, V here, same thing. Okay. So make sure you can find, try to find the I and V values for each of those. Okay. Okay, next time I'm gonna talk about capacitors in series and parallel. If you have any question, please let me know.